Hello everyone. I hope you enjoyed the last video. So here I'm going to actually show you how to find the GCD of this two number, and here also I'm going to use the Euclid algorithm. But what I have decided that I'm not going to actually show you all the steps like the transformation from A to BQ plus R. Alright, so but I'm going to actually show you all the GCD call here. Okay, for example, like GCD of 1 7 3 6 9 and 5 4 7 2 it is going to be same as GCD of B. So 5 4 7 2, and if you find the A equals to BQ plus R, where A equals to 1 7 3 6 9 and B equals to 5 4 7 2, you'll find the R value should be 953. Okay, all right, so I'm going to actually just show you all the GCD function call here, and please try that at your home with all the transformation of A to BQ plus R, and verify whether your result is also same. Okay, and that should give me the value of GCD 953, okay, and 707. All right, and that should give me the value same as GCD 707. Okay, and the remainder here is going to be 246. All right, so that should be that is same as 246. Okay, and their remainder is going to be 215. So you can see that is going to be, actually we are going to need a lot of steps. So GCD of, we're going to find 215, and here remainder is going to be 31. Okay, so that is going to be same as 31. All right, and remainder is going to be 29. So I'm going to find out GCD of 29, and remainder is going to be, now it's actually kind of easy, remainder is going to be 2. Okay, so that is going to be same as GCD of 2. All right, and if I divide 29 with 2, remainder is 1. All right, so now this will be same as GCD of 1, okay, and 0. All right, because if you divide 2 with 1, all right, remainder is 0. And now we got our this step, we know that GCD of any value and 0 is same as the this value 1. Okay, all right, and if the GCD of two number is 1, that means they are relatively prime. All right, now we are going to see another way to find GCD value, and we can do that actually using prime factorization. So one of the most important theory in number theory is the fundamental of theory of arithmetic, says that any number greater than n or equals to 2, all right, it can be written as a combination of prime factors, okay, like p1 p2 p3, and like alpha 1 alpha 2 to the power alpha 1 alpha 2 alpha 3, like that, as a multiplication of these prime factors. Okay, so here we are assuming that these are ordered in ascending order. Okay, so let me show you a couple of examples. All right, and then we are going to see how we can find out the GCD of two value using this prime factorization. Okay, all right, so let me use our last two values as an example. I'm going to use A equals to 270 and B equals to 192. Okay, and I'm going to find the GCD of these two value using prime factorization. So every value n greater than or equal to 2 can be represented as this form, where each of the p1 p2 p3 they are prime number. Okay, and they are sorted in ascending order. So here it's like that, p1 is less than p2, p2 is less than p3, like that, and we can actually do it like that. Okay, So let's see 270. I can find the prime factorization value of 270. And how I can do that? So first actually I'm going to divide it by our first prime number 2. All right. Then I will have like so I will have like 135. Okay, if I divide 270 with 2, it will be 135. Then I'm going to actually represent again 135 using, I'm going to divide it again with the prime numbers. Okay, so now 135 is not divisible by 2, so I'm going to try it with 3. Okay, the next largest prime number, 3. So whether this is divisible by 3, we know that we can actually just add up all the digit, and if the summation is divisible by 3, we can say that this number is divisible by 3. For example, here 3 plus 8, I'm sorry, 3 plus 5, 8 plus 1, 9 is divisible by 3. So that means I can say that this number 135 is divisible by 3. So that should give me actually 3 times 45. Okay, so this is same as, so again I can divide 45 with 3, so it is, I can write it like that. So sorry, 2 times 3 times 3 times, again I am going to divide 15 by 3. Okay, so that is my prime factorization of 270, because 5 is the prime number. So this is same as 2 to the power 1, 3 to the power 3, and 5 to the power 1. Okay, now with same as 192, let me just show you how it is going to look like. I'm going to divide it with 2, so 2 times 96. Okay, so again this 96 is divisible by 2, so 2 times 48. Okay, and 48 is divisible by 2, like 24. So, and you can see actually it's something, it is going to be 2 to the power something. Okay, times something. All right, so 24 means actually 2 to the power 12, and 12 means 2 to the power so 24 means 2 times 12, and 12 means 2 times 6. Okay, and 6 means 2 times 3. Okay, so let me just write it down what actually I'm going to find it. All right, so it will be actually 2 2 2 2 2 and another 2, 1 2 3 4 5 6. I'm going to find 6 to here, 2 to the power 6 times 3 to the power 1. Okay, so that will be my prime factorization of 192. Okay, all right. Now if I can represent any two numbers as this form, okay, as a combination of this prime factorization, okay, with their power, all right, then the GCD value of A and B, I can actually I can find the GCD of A and B using this prime value. Okay, and how this is going to look like, the prime P1, as I'm going to take the minimum of alpha 1 and B1. Okay, whichever is the minimum value, I'm going to take that. For P2, I'm going to take the minimum of alpha 2 and B2. And same as like for P3, minimum of alpha 3 and B3. So these are the common prime factor for A and B. Okay, P1 is the common prime factor for A and B. Okay, now for Pn also I'm going to take the minimum of alpha n and Bn. So let's now look at how I'm going to find the GCD of 270 of 192. Now GCD 270 has three prime factor, 2, 3 and 5. Now 192 has this 2 prime factor, 2 and 6. Now actually I can make them as like same using adding 5 here, but with the power 0. Okay, that's same, right? So it has a prime factor 2, 1 power is 1 and power is 6 here. So I am going to take the common prime factor 2, but I am going to take the power as the minimum value, minimum of 1 and 6. So that will be 1. So for prime factor 3, the minimum value is 1 here, between 3 and 1. 1 is the minimum, I am going to take 1. Now for prime factor 5, I have here 1, I have here 0. So I'm going to take 0. Okay, so that gives me the value 6. Alright.